Hey guys, statistics. This is one of the in-need areas that we all voted on. I'm focusing on mostly Year 11 statistics here because the Year 12 statistics with bivariate data and normal distribution, we did them pretty recently. So let's look at the Year 11 stuff, which does come up a fair bit. I've broken it down into two of the sections on that course contents page I gave out. One was classifying and representing data, and the other one is your summary statistics, okay? Classifying and representing data, the important things are: know the difference between taking a survey or information from a population versus sample, all right? So something like a population is a census, right? Because they give out this form and everyone in Australia has to answer it, okay? Or every household, I should say. So it asks everyone. A sample only asks a portion of people. Now, one thing that's important there, a population just means it asks everyone in that category. So it doesn't mean that if I have to ask all of Australia or all of the world. It means if I need to know something about Year 12, I ask all of Year 12, not just our class, for instance. That would be a sample. So I've written there some pros and cons can be asked about population. It's more time, more money to ask more people, but usually it is more accurate. Whereas a sample, it is quicker, it's cheaper, but it may not be as accurate because you're not asking everyone. Then we've got numerical and categorical data. So being able to be given a question and answer what kind of categorical numerical data it is. So in categorical, it breaks it down into two different sections. We've got ordinal and nominal. Ordinal has an order. So it's pretty easy to remember ordinal, order. Nominal, there's no order. So categories that need an order is something like small, medium, and large. Okay, the categories, and there's an order to them, all right? The other one is eye colours. It's something that needs no order, okay? So they're categories, but there's no order to them. Then you've got numerical. In numerical, it breaks down to discrete and continuous. Discrete are whole numbers, so things like the number of siblings you have or the number of televisions you own, because you can't have 0.3 of a sibling or 0.4 of a television. Whereas continuous are those decimals and fractions, the ugly numbers, that the numbers are just continuous. There's no limit to them. So like your height or your weight or time, okay? So you could keep narrowing time down and get it very accurate, okay? All right, then the big one is Pareto Charts. Now these Pareto Charts, please get your head around and expect one in your HSC because they're a brand new thing on the syllabus, and basically there's been multiple hints Ness has given us where they've said, yep, Pareto Charts, know them well. So basically it's a way to show data, and we base it off the 80-20 rule. So a lot of businesses create Pareto Charts because they say that 80% of problems a business has comes from 20% of the issues. So it's the 80-20 rule, but you'll soon see what I mean by that. Things you need for a Pareto chart. You need a table and preferably, definitely the table needs to be put in order from highest frequency to the lowest frequency. You need to add a column to your table that is the cumulative percentage column, and I'll show you soon how to calculate those. Now on the graph it says the left axis is your frequency, the right axis is the cumulative percentage, which I've just written there as the percent, and these must be in scale with each other. So let's have a look at an example together. Now you need to be able to analyse and construct these. So you could be given one and you have to answer questions about it, or you're constructing one. So I'm going to add in my cumulative percentage. So %, I'll just write that column. And basically now I'm just going to fill in the cumulative percentage of each one of these rows. Now, how do we work that out? Well, it's as simple as you take your cumulative frequency, you divide it by the total frequency, and then to turn it to a percentage times by 100. Okay, so for instance, I'll show the working out for the first one. My cumulative frequency is 65. I divide it by the total frequency, so you could either add up your frequency column, the sum of frequency, but we all should know that that's the same thing as the bottom number here. So divide that by 112 and then times it by 100, and that will give you your cumulative percentage for that row. And to the nearest whole number, I get 58%. Now, I should mention what this piece of information is about. So this was reasons that paint can be faulty, okay? So a painting company went down and they said, okay, what are the main reasons, what are the main complaints we have? And so when people have faulty paint, these are the 65 people said that was because there was dirt in paint. 21% people were sad. I'm guessing that just means they didn't like the colour, perhaps, but these were all reasons why people complain about the paint of their house, perhaps. So the next one, again, take your cumulative frequency. Remember, the biggest mistake people are going to make is accidentally do frequency. It's cumulative frequency over the total, times it by the percent. So keep going and find all your frequencies, all your percentages. Okay, I've gone ahead and done that. You should always end up with your 100%, okay, because that's your final. So now, to put these on your graph, note what I said on part 3 up there. Your left axis is your frequency, your right axis is your percentage. So this, I've just given myself a little grid here. So, I don't need to write left, I need to write frequency. And then cumulative percent. I'm just running out of room there, but cumulative percent, that says that, yep. All right, now we've got to fill in information. The most important thing is that you put your frequencies in with the highest to the lowest, okay? So I'm going to determine my highest frequency is 65. So what that means is I want to think about my scale. I might go 1, 2, 3, 4, 5, 6, probably best going up by tens. And then I know that halfway are the 5s. Now remember, histograms, we need to leave a half gap at the front and the back, okay? So 1, 2, 3, 4, 5, 6, 7, 8. I have 8. Let's hope I did 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. I just need to add one more in. Okay, so what that means is this line here, I'm going to put my first, so I'll just put dirt, then sad, filling it in. What I then do is I go up to my frequency, so dirt in the paint had a frequency 65, so with a ruler, we go up to 65, put my column, go down. So notice I've left my half gap there, and that's the same thing you're going to need at the end. So go ahead and do that. Okay, I've put that in, I just need to finish labeling them. But what I want to just quickly look at is now how you do the second part. So we're halfway. Now what we need to do is put in our cumulative percentage. So we need to have, so my top of my graph is here. So in fact, I don't need that top column or top row. But I know that that needs to be 100%. So now what I need to do is split up my 100% so it's the same scale. Now you can do this a few ways. If you're on pen and paper, which might be much easier than me on my screen, you could just measure how many centimeters that whole line is there from 100 down to 0, and then split up into 10, okay, and then you can go up by 10 and just put it every centimeter, or so let's say that it was 20 centimeters, then you know that every 2 centimeters you need to go up, and then you can go up by tens. However, on here, I can't do that. The other thing is use your grid. So there's 1, 2, 3, 4, 5, 6, 7. So there's 7 different lines here that I could break down 100 in. So if I did 100, divide that by 7, that's 14. So each one of these are going up by roughly 14. So then that would be 28. And keep going up like that. So then 43. And I've made a mistake in my calculations somewhere. No. Oh, okay, I was just rounding because it technically is 14.2 something. So that's why I'm slightly out, but that's okay. We're roughly going up. You could probably do one decimal place. It was 14.28, so 14.3, and then times that again. So your numbers might be slightly different here. But basically, if I was on pen and paper, I would just measure the length of that line in centimetres and go with option 1. And then how many centimetres it is, break that up into 10, so you can just go up by 10% each time. So the numbers on here are nicer numbers rather than this. It doesn't matter which one you go, but you can see a limitation there. I need to do my decimal places because 85 needs to add 15, not 14 to get to the 100. And that's just from my rounding. But let's get to the idea behind it. Now what I need to do is fill in my cumulative percentage. So my cumulative percentage for the dirt in the paint, that was 58. So what I need to do then is go, okay, well, I find 58% in here, all right, and it's just above that, so I put a dot smack bang in the middle. So now for sad, I go to 77. I go, okay, but remember, it's not 77 on the left-hand side, it's 77 on the right. So I go, okay, well, yeah, that's just above there, so it's going to be roughly about there. And yours will be better on paper. So you keep going through. The next one was 88. So now I go, okay, 85, 88. The idea is going to flatten out, and then you link it up to 100, okay? So then we had 99, 97, I think I've done that. Double check, 58, 77, 88, 92, 96 is a bit higher. And then we draw straight lines with your ruler in between all of them. And they should always be increasing. Mine's a bit dodgy. And that there is your cumulative percentage. And there's your Pareto chart. The last thing, your cumulative frequency graphs. The only thing I just wanted to look at quickly here is if you didn't get given the table over here and they said what score did the numbers, what frequency is the number 6? Okay, remember this is a cumulative frequency. So you go, okay, well the number 6, it got about 23, so halfway through, as its cumulative frequency. So again, this is pretending I didn't have this. And then the number 5, what did it get? It got 18 by the looks of it. So the score that number 6 received is this one minus this one, okay? So then the score of 6 will be 5 because it's the difference between them, because this is a graph of a cumulative frequency. Cumulative frequency graphs always only ever increase as well. The other thing we can do with the cumulative frequency graph is find the median really easily. You find what the highest value was, and you can see there's 25. Halve 25, okay, so I'll say here median. The highest, then divide that by 2, and then you go to it. So 12.5, go to 12.5, which is just here, and we go out until we hit it, which is the score of 5. So therefore, median, so it's the 12.5th score equals 5. And there's my answer.